Hey there, how's it going? So in this tutorial, we are going to be creating a simple target clicking game using the processing module for Java. So, before we get started and taking a look at how all this is going to work, let's first see what it is that we're going to be building so we have some context to what we're actually doing. So this is my pre-made version, and if we run it, we can see that we got a bunch of different targets kind of bouncing around and some text telling us how many targets are remaining. And if we start clicking them, you can see that every time I click them, they change color until I've clicked them 3 times, in which they basically disappear, and the text updates saying that there's one less target to click. Notice that all the targets are of different sizes and are moving at different speeds. And so that's going to be the thing that we're going to be creating. And after we finish, then you will be adding on to this to add your own features and whatnot to do whatever you want to do. So, let's stop that. And if you open up the assignment, you will see that the main class just looks like this. And that is perfectly normal, and we're not going to do anything in this class at all. Instead, we're going to be treating what's called the sketch as our main class, and that's going to be where we put pretty much all of our driver code. Okay, so this we're not touching at all. We go over to the sketch, we can see that it's got these 3 different methods that all return nothing. There's settings. This is kind of like our bit of like an initialization, actually, so it's set up, to be honest. And there's probably some reason why they separate them. I'm not entirely sure why, but what size is doing is it's setting how big the game window is going to be. So this is 400 pixels by 400 pixels. Let's boost this up a little bit. Maybe let's do 600 by 400. That seems like a pretty good size. Setup is also kind of our initialization. This is going to be where we actually put in most of our initialization code. And right now, all it's doing is setting the background to kind of a ugly green color. And then this draw function gets called every frame. And so this is saying, what do you do every frame of the game? And all it's doing is saying, set the fill color to white, is what this is doing. And make a circle. It says an ellipse, but it's actually a circle. And the way you can tell is the first 2 parameters are saying where to put it, and it's saying put it wherever the mouse is, and make its horizontal size 25 pixels and its vertical size 25 pixels. And because these 2 are the same, it's going to make a circle. But if I made it different, then it would make more an ellipse. Okay? So this is saying every frame, draw a circle wherever the mouse is. And if we run it, we'll see that's exactly what it does. It fills the green with the ugly color, that's done in initialization. And then it's drawing circles, but notice that the previous circles do not disappear. The reason why that's happening is because we've only created the background once, right on construction. Every frame, we keep whatever's already there and just add on top of it. So that is why you're seeing this effect of a bunch of circles just being drawn on top of each other. Okay? So that is the code that we are starting with. We're not going to do a whole lot with this right away, because what we need to do is we need to create a target class that's going to be creating all the targets for us, and then we'll come back to this to actually create the targets and control what they're doing. Okay? So if we want to make a new class, we need to make a new file. So let's do that. This is going to be the target.java. Oh, this did not get cleared away. You didn't see anything. So, brand new. And This is going to make use of a couple libraries. So before we do that, let's first make the class. So this is going to be a public class called target. Has to be called target. Remember that the name of the file and the name of the class have to match. And in this, we are going to need to use a couple additional modules. So we're going to make use of the color package to help us create the different colors that we want. And we are also going to import the math library so that we have mathematical functions, particularly the trig functions. And that's going to help us with all the motion and the bouncing off and whatnot. Okay? So, we create a new class. First thing we need to do is create all of the class variables that we're going to be needing. The main thing that all of your game objects in processing is that they are all going to need to have their own copy of this sketch object, this main sketch object, so that we can call it and all of its draw functions. Okay? So we're going to have a sketch object called sketch, and it is going to be private. So our own private sketch object. Next, let's make our colors that we're going to want to use. There's a couple ways that you can do this. And I found that this is probably the easiest way, because otherwise if we treat colors how it's done in processing natively, we have to keep track of all three RGB values, where I would like just to have a variable that I can treat as the color and pass it to it. So these are also going to be private. They're also going to be static because we don't want them to change. And each color is going to be represented by an integer. Okay? So we're going to create the color white first. That is going to be a new color. Wait, did I just say that it's going to be an integer? How is this going to work? I will show you. So we're going to create a new color object first using the color package. And it needs the RGB values for this color. White is all the colors to the max, and max is 255, so 255 red, 255 green, 255 blue gives us white. And now that we created this color, we're going to get its RGB value. And that returns an integer that represents this color. Okay? So even though it seems like we're creating a color and assigning it to an integer, we're actually not. We're creating the color, then getting the integer that represents it by using this RGB parameter. And so we're going to do that a couple more times because we don't just want the color white. We also want red, green, and blue, because you notice that those targets were turning colors as you clicked them. So let's create red. Let's create green, and let's create blue. Note that these are in all caps. All caps indicates that these are static, never changing, kind of almost like a global variable, but they're not global variables. And then the values that we're going to use, well, red is going to be 200 red, and then 50 of the others, just so that we don't get a super saturated red color. And same kind of idea with the others. So green will be 50 red, 200 green, and 50 blue. And blue will be 50 red, 50 green, and 200 blue. There we go. And those are all the colors that we're going to need for our target. Feel free to change these to whatever you want. Those are just the ones that I'm going to use. Then, using that, we are going to create an array that keeps track of the primary colors that we're going to use. So this is going to be also a static integer array. called primary colors. These are going to be the main colors of each target. So if you notice when we're watching them bounce around, they're made of 3 different circles, where the inner and outermost circles are the color, and then in between them is a white color, and that's going to be the secondary color. So primary colors is going to be represented by these, and that's going to be a new integer array with these values in it. Red, blue, and green, like that. I'm doing it in this order because I want the first one to be the last color that gets shown, and the last one to be the first color that gets shown for the target. The reason why I'm doing this is because we're also going to have a hit point that I'm going to use to identify which one of these colors we should be using. So as hit points goes down, we move to closer to the first element. We're also going to need to have just a private int that is whatever the current primary color is, not equal. And so that will be either the green, the blue, or the red, depending on what color should be shown for that particular target. Then we're going to need to have some more variables to keep track of kind of the kinematics moving part of what's going on, as well as the drawing stuff. So for example, we're going to want to have something, a float that represents the radius. We're actually going to have a private diameter as well. The reason why I'm doing this is because a lot of the calculations that we're going to be doing for calculating bouncing off of walls, and if you clicked on the target, it's going to use a radius, but processing's drawing of the size of the different circles is done with a diameter, so we're going to have one for both. We're also going to have a private integer that is the number of hit points that this target has. And then we need some stuff for the kinematics, the moving around. So we need an array of floats that represents the position, and this is actually going to only control have 2 different slots in it. So the first slot in our array is going to be its X position, and the second slot is going to be its Y position. And we're going to have something very similar. So I'm just actually going to copy it, but rather than representing the position, it's going to be its velocity, or vel for velocity. So P for position, V for velocity. And this is going to once again have the first thing be its X velocity, and the second number is going to be its Y velocity. Last thing that we're going to need is another float that's going to be just how fast it's moving. Okay? And those are going to be all the different things that we need for our target. The different colors we're going to use, stuff for its size, number of hit points it has, and its speed and position. Okay? So, let's start with creating the functions, or at least identifying the functions that we're going to need for our target. And so any game object that you create in processing should probably have at least these 3 methods. Okay? Of course, you're going to need to have the constructor method, right? And all constructor methods are going to need to take in this sketch where everything is going to get drawn to as a parameter. So sketch. That's the only thing that you're going to need to take in. And we'll fill in the rest of it later. But you want to have at least the constructor method that takes in at least the sketch object where everything gets drawn to. Okay? The other two methods that every game object should have is a draw method. This will not return anything. All it's going to do is be responsible for drawing the target. And so all of our drawing happens here. And another void method, which is going to be our update method. And this is going to be responsible for actually updating. Just put spaces there, looks a little bit nicer. But this will be actually responsible for updating the position, the velocity, checking if it's bounced off of anything, etc. Okay? So any game object that you make in processing, or really any kind of game engine that you end up ever using, is going to have these three. Some of them get away with just two, but it's not typical. Certainly you always will have the constructor method, which says, okay, how do you initialize this thing? But the draw and the update is usually kept separate, not only because they do different things, but in modern game engines, the frame rate or the update rate for these are typically different. So, for example, you might be playing a game at 120 frames per second. That's only updating the draw 120 times a second. The update, so the physics updating, typically happens at a much lower speed, maybe only like 40 times a second. And the reason why is because drawing is typically really fast, doesn't take a whole lot of processing power, so it can do it a lot. But the actual updating of the physics takes longer, so this is done less often just for keeping the game performance up there. Drawing will typically do a little bit of interpolation of where it thinks it should be, but the actual updating of the game physics and whatnot, that typically happens at a lower rate than the actual frame rate. And so that's why those two are done differently. With that out of the way, we're going to have a couple more functions that we're going to need for our purposes. Pretty much all of these are going to be private. None of them are going to be public. And really, we don't need to have access to pretty much any of these outside of this class, except for the hit points. So we're going to create an accessor method, or a getter method, for the hit points. So public, this is, we're going to return an integer, and it's get the hit points. And we can write this out right now. This is return hit points. There we go. So we created the only accessor method that we need so that we can get access to how many hit points this particular target has outside of the target class itself. After that, we're going to have a bunch of helper methods. And helper methods should not be called outside of the main this class. So these are all going to be private. The first one we're going to create is one for updating the position. So this is going to not return anything. It updates position. We're going to have another one that handles bouncing off the walls, because you saw that the targets were bouncing off of the different sides of the window when they hit them. So we need something that's going to handle that. And then we also are going to want some stuff to handle the interactivity, because as you saw, when I clicked on targets, stuff happened. So we're going to want some functions that are going to help with handling that kind of stuff. One of them is going to be public. Actually, they're both going to be public, because the actual clicking is not handled in this class. It'll be handled in the main driver code. So first one is going to be returning a Boolean telling us whether or not the player clicked on this particular method. So we're going to call it, or not method, sorry, this target. So did they click on this target, true or false? And so that's going to return a true or false. And finally, we're going to have another one that says, okay, if we clicked on it, what do we do? This is not actually going to be a Boolean, sorry. This is not going to return anything. So, Boolean, did we click on it? If we did, what should we do? Okay? And that's all the different methods that we're going to need in order to have this target do what we want to do. So, with that out of the way, let's get started on the constructor method, because that's going to be where most of the work takes place. So, we need to assign the sketch that got passed to us to our variable we created for it. So this sketch is going to equal to sketch, the one that we passed to it. Now we have access to all the things that we need from the main processing library. And you notice that there's going to be some random stuff happening, like going in a random direction, being a random size, etc. I didn't import the random module here. That's because processing has its own built-in random method that is well suited for this, because it's always going to give us floats. And when you're doing game stuff, most of the time you're going to be working in floats rather than like double or int. Okay? So, that's what we're going to do. So, first we're going to randomly determine how big this thing is going to be. So, this diameter is going to be, and we're going to use the built-in random number generator in our sketch. So, sketch, and then just random. And random is overloaded such that if you give it one number, it will give you something between 0 and that number. And if you give it two numbers, it will give you a number between the first number and the second number. So we are going to want to have a diameter that is between 30 pixels and 50 pixels. There we go. Okay? So we randomly create the diameter. Now we know the diameter, we can get the radius real quick. So let's do that. So this radius equals this, or not even, we don't even have to say this diameter, we can just say diameter divided by 2. Remember, I don't have to necessarily specify this if it's clear that there's only one thing it could refer to. In your constructor, it's typically best to always say this and this and this. But once we get down to all the other methods, we're not going to have to necessarily say this all the time. But remember, this always refers to these things. Okay, so we've got the radius. Next thing we need to do is to have a random speed. So let's do that. This speed is going to be, once again, using the built-in random number generator in our sketch object, and it'll be between 2 and 4 pixels per frame. Okay? So that's what that represents. How many pixels does it move per frame? Might seem like it's going pretty slow, but if we're running it at like 30 or 60 frames per second, that ends up being a lot of pixels every second. Now that we got the speed, I guess before that we should actually get the position. Let's move that down and let's get its position first. So this dot position, we're going to get the X position and create that first. So once again, getting the random number generator. And we don't want to spawn any targets such that they fall outside of the window, even a little bit. So if we're looking at the X, we're looking at how far left can it be, how far right can it be. If I put in 0, then this is representing the middle of our target. And it's going to go, if I say put it at 0, it'll be half cut off. So I want to offset it by its radius in order to ensure that it will stay within the window. So the smallest it should be is its radius. And how far to the other side it can go? Well, we would need to know how big the window is. And guess what? Passing it to sketch, we can access how big the game window is. We can do that by saying sketch, get the width of the sketch, that's how wide the window is, and subtract the radius on that side. And that will now make sure that we have an X position that is going to keep it within the window. We'll do exactly the same kind of thing, but now we'll do it for the Y. So second element in our array is going to be the Y, and we don't want the width anymore, we want the height. Okay, so that creates a random position somewhere in the window, ensuring that the target's going to fit entirely within the window. Now that we got this, now we can actually take a look at the velocity. So we got the speed. Before we do any work with that though, we are going to now have to have a random angle that's going to be its initial direction it's traveling at. So let's create a random angle. This is going to be a double. And the reason why it needs to be a double is because we're going to be using the math library for this, and the math uses doubles, not floats. Okay? So even though they're both representing decimal numbers, we have to make sure that we're using the correct data type for what it's expecting. So let's do that. So we want a random angle. This random angle, since we're using sketch, it's expecting to be passed a float. This will actually give us a float, but it's okay. It will just upconvert it to a double. So I could make this a double or float instead, but I can't automatically down convert from a double to, I can't down convert. So I need this to be a double so that I can just pass it directly to the math library rather than have to convert it first. So we're going to need to cast this as a float, and we want to create a random number between 0 and 360 degrees. But there's another problem. Math library does not use degrees. It uses radians. So what's the equivalent of 360 degrees in radians? It's 2 times pi. And so we will just use the math constant for pi, multiply by 2, cast it to a float, and use that to create a random number between that and 2 pi. And that's going to be the angle that it goes at. Okay? Now that we got the angle and we got speed, now we're going to be able to actually get the different velocity components. So kind of like what we did for the position, we're going to get the x component of the velocity, and this is going to be the speed times, and remember this has to be a float. Math is not going to give me a float, it's going to give me a double, so I need to cast whatever it's going to give me as a float. And I need to use the cosine method to get an x component. If you remember from your physics, cosine is going to give you your x component, sine is going to give you your y component. Okay? So, this is a double because math needs it a double. Math is going to return a double, but I cannot automatically down convert it, so I need to manually cast it to a float. Then I can multiply by the speed that we got and assign it to our array. And now let's do the same sort of thing, but let's do it for the y component. So the y component is going to use sine. And that's it. That's the only thing that's different. After that, we only have 2 more things to do. We need to set how many hit points it has. And it's going to have 3 hit points. So I need to click on it 3 times before it disappears. And I need to set what is its current color. So this dot primary color is going to be, and I told you that we're going to use the hit points as a way to index which color we want to use. And this is going to be how we do it. We get our primary colors, and I want to get the one that's at HP minus 1. HP minus 1 is going to give me 2, so it's going to give me the third thing in our list, which is green. Perfect. And there we go. That is our constructor method. Everything created, it's going to go at a random size, it's going to be spawned in a random location, and it's going to go in a random direction. Exactly what we want. Alright. Let's now do this draw function. So, Sketch is a little bit weird in that you don't set the color when you're drawing it. Instead, you set the fill parameter. Then anything that you draw after that is going to fill with that color. So, that's going to be the first thing that we need to do, is we're going to need to get our sketch, call its fill method, and we're going to want to fill with whatever the color is of our target. So this is going to be first drawing the outermost circle for our target. Now that we have done it, this is going to be filling that. Now we need to actually draw it. So we're going to draw it with that ellipse method that ellipse, I can spell. And we need to give it its position as well as how big it is. So X position is going to be position 0. Y position is position 1. The size is going to be diameter by diameter. Just like that. And I don't need to use this because it's clear by context. These can only be referring to one particular thing. That draws the outermost circle. Now we need to draw the second circle, which is that white one. So, sketch, fill, change what our fill color is to, no, don't go away, to white. And now draw another one in the same position. However, we need it to be smaller. So not the diameter, well, how about 2/3 of the diameter? There we go. A little bit smaller. And now we need to draw the innermost circle on top of that, which is going to be the primary color again. And it's going to be even smaller, so 1/3. There we go. And that's our draw function. All done. That's going to draw it for us. Update is going to just do two things, because there's only two things that it needs to check for. It's going to first need to check if it bounced off a wall and handle that. So we'll write that soon. And we're also going to need to update its position. So our update function is just going to call these two that sub-update functions, just so we can kind of organize ourselves a little bit better. This is already done, so update position, that's actually going to be pretty easy. The way that it works is we take our X position and we're just going to add our X velocity. And we're going to do the same thing for the Y. Take our Y position, add our Y velocity. That's it. That's all there is to updating our position. At least when you're moving in a straight line at constant speed. If you wanted to get really creative, then you could start adding like acceleration and stuff like that. But for just something simple with a fixed position and fixed speed, or a position and a fixed speed, that's all you need to do. Wall bounce, that's going to be a little more complicated. but not that bad. So what we need to do is we need a couple if statements that are going to check to see if they hit a wall. And then we are just going to change its velocity if it did. So we're going to take a look at the two side walls. So did it go too far to the left or too far to the right? How do we check? Well, there's a bit of a clue when we were setting where is it allowed to be. If it is more to the left, then its radius, it's hit the wall. And if it's more to the right, then the width of the window minus the radius is hit the right wall. So that's how we're going to check to see if it hit either wall, or at least the left and the right wall. And top and bottom is going to be pretty much the same thing. So let's make a statement to check for that. So if the x position is less than its radius, then it hits the left wall. Or if its x position is greater than the width of the window minus the radius. So hit one of our two side windows, or two sides to our window. What do we do? How do we change the velocity? Well, we just make it so that the x velocity, the horizontal velocity, changes direction. Okay? And how do we do that? Well, we just get the x velocity, and we multiply by -1. And there you go. That's going to now change its velocity so it starts going the other direction. Note that it's only changing its x velocity, not its y velocity. So, for example, here's my wall, and it's coming up. It should start going, I came in from the left, hitting left, I should now travel to the right, but it also is pointing up, and I should still go up. So, coming in, and come out like that. Okay? So y velocity stays the same as it was, only the x velocity changes. And that's why we're doing it like that. And y is going to be exactly the same thing. Now we're just going to look at the y velocities. We're going to look at the top and the bottom walls. So I want height here instead. And I need to flip the y velocity so it goes up if it's initially going down, or down if it's going up. That's it. That's all we need to do for bouncing off of a wall. And now we only got two more methods to make. Alright, did click. How do we tell if it clicked it? Well, what we're going to do is we are going to take a look and find out, okay, where on the screen did they click, and what is the distance between where it clicked and the center of that target. And if that distance is smaller than the radius of the target, they click the target. Okay? That's the logic of how we're going to approach this. If the distance between where they clicked and the center of the target is less than the radius of that target, they click the target. And we return true. So, how do we do that? Well, we need to, get where they clicked and find out what's the distance. Best way to do that, I would say, is we're going to create a new variable. I'm going to call it dx. So this is going to be like the difference in the x positions. That's going to be, the x position of the target minus, then get the sketch, and we'll get the x position of the mouse. That's how you get the mouse's position. Same idea here. We're going to do what is the difference in their y positions. So position of the y position of the target minus the y position of the mouse. And now that we got the difference of the two, we can use Pythagoras in order to actually find out what that distance is, because this kind of creates a triangle between the 2 points. This is a right triangle. Very important. So, how do we figure it out? Well, I'm just going to do this in kind of a one line. I'm going to write out Pythagoras for a triangle with these side lengths to get the hypotenuse. Hypotenuse is the distance between the two. And then check if it's less than the radius. So I'm going to need to take a square root. And inside that square root, I need to square our two values. So the way we do that, we get the power method of the math. We want to square the x, and then we want to square the y. So this 2 is the power of, and then this is what you're doing the power of. So this is dx to the power of 2. And remember, dx is the distance between the two x positions. And then, is this less than or equal to the radius? So it's going to calculate what the distance between the two is using Pythagoras. Check if it's less than the radius, and return whatever the result is, true or false. Okay? There we go. And then on click, what should we do if this target was actually clicked? Well, remove 1 from the hit points. Minus minus removes 1. And we need to change its color. So primary color is going to be, and just the same as before, HP minus 1 to get the right index. And that will change what color it is. Okay? And there we go. That is our target class. How about we go into our main sketch object here and set some stuff up to see if it's actually working how we want it to. So we're going to want to make some targets. Best way to do that would be to store all those targets in some sort of list so that we can keep track of them all and just iterate through the list in order to do that. We don't want to use a proper array for this because arrays are a fixed length and we want to be able to remove or add them as we see fit. So that means we're going to need to import some stuff. We're going to need to utilities. We're going to need the array list. Works very similar to the list does in Python. And we're also going to need to at least have a little bit of color as well, at least for our background. Okay, so now we can define what are going to be our main parameters, variables for this. We're going to need something that keeps track of all the targets. That's going to be our array list, and it's going to be private. So create a new array list that's going to hold targets. Call it targets, and it's just going to be a new array list. So it doesn't have any targets in it yet, but it's now prepared to start holding targets for us. Next, we're going to need to have our background color. So let's make the color that we want. So this could be this is all going to be private. Private static int. We'll create white, and we'll do it the same way that we did before. So create a new color, give it the RGB values for white, which is 255, 255, 255, and we'll say get RGB to get the integer that represents that color, and assign it to our white. Great. One last thing that we're going to need is we're going to need something that keeps track of how many targets do we want to create. So once again, private static int starting targets is, we're just going to have 10 targets to start off with. Okay. This we're going to leave how it is. We're going to do all of our initialization in the setup instead. And we're not going to do the background there because that's actually a really dumb place to do the background. As you saw at the beginning of the video, we just kept on drawing over top of it and it didn't refresh itself. But we are going to want to set what is the frame rate for this thing. Because if we don't set the frame rate, then this is going to run as fast as it possibly can. And sometimes it'll do frames very quickly, sometimes it'll do frames very slowly, and it'll give the impression that it's like freezing all the time and hanging, and it'll be a bad experience. So we'll give it an initial frame rate of 30 frames per second. Seems pretty reasonable. We can change that later if we want to. And next, what we're going to need to do is we're going to need to now create all of our targets and add them to our array list here. So that sounds like a job for a for loop. So we'll do for. Let's use I as our iterative variable. Start off at 0, so nothing really fancy here. While I is less than our starting targets. So we want to create 10 of them, so that's why we're going to do that. And I++. Nothing really fancy there. And so to create the targets and add it to our list, we're going to do targets. We want to add a new target. And remember, our target constructor method takes one parameter, and that is this sketch. How do you pass this sketch to it? Well, this. There we go. And that will now create a new target and do it 10 times. So our array list has 10 targets in it. Draw function, we're not going to do quite yet. Instead, while processing does do everything just in the draw, I am going to recommend that you add an update method as well that you can use to call all the update methods and keep the draw and the updates separate. Okay, so I'm going to create a private update method. It doesn't return anything, so void. And we also are going to need to have a most clicked method. This is special to processing. Often you typically do this with some sort of event handler, but the way processing does it, it has its own particular method for handling mouse click events. And so we need to add that as well. So void mouse clicked. It's not going to return anything, but this function gets called whenever you click your mouse. Okay? So, drawing. This is going to be kind of more like our main loop of what do we need to do. So before we draw anything, we're going to want to call our update method. Always update before you draw. And then we're going to actually do all the drawing. So, first thing we draw is we need to redraw the background to get rid of everything that was on the previous frame. So, redraw the background. We don't want any of that stuff. We're just going to make it white. So draw a nice white background. After that, we need to draw all of our targets. That sounds like another job for a for loop. So we're going to loop through our array. So for target and targets, call its draw function. The update is going to be really similar to that. We're just going to loop through all the targets, but rather than calling the draw function, we're going to call their update function. And that should at least allow us to see the targets bouncing around. We're not going to be able to click on them yet. That hasn't been fully fleshed out. But this is a good point to test to see if we're on the right track or is there any bugs that we're going to have to fix. let's try it out. Oh, what did I get? I got all sorts of errors apparently. Oh, I imported wrong. That's easy to fix. Java should not be capitalized when doing it. There we go. Try it again. Hey, there we go. Funny how just one thing being capitalized gives you 3 different errors. But they're all bouncing around. Looking pretty good. Different sizes, different speeds. Trying to click on them, but nothing's happening, as I said. But so far so good, right? So stop that. Let's get the clicking done, and then we will do the text, and we'll be all finished. So, when we click, what do we need to do? Well, one thing that we're going to need to keep track of is when we click, we're going to want to know, did we destroy any targets? We can't modify the array while we're looping through it, so we're going to need something to store any target, just in case. So we're going to do that first. I'm just going to call it destroyed. And set it to null initially. So we're going to use this in case if one of them got destroyed. So, first thing we want to do, really when we think about it, is we're going to want to loop through all of the targets and see if they clicked on any of them. So, that's what we're going to do. Create our loop. Loop through all the targets. And let's see, did they click on any of the targets? So if they did click, so remember that our function gets the mouse position right away. So we already know from this being called that they clicked on it, and this already knows where the mouse is. So that's all we need to do. Did they click on it? Then there's 2 different things we need to consider. First is, did they destroy the target because they clicked on it 3 times? How do we check for that? Well, we use that accessor method to get HP in order to figure out how many hit points does that target currently have. So target get HP is at 1, meaning it is on its last hit point and it just got clicked. Well, we would want to remove that from our array, but we're currently iterating through the array, so we can't do that quite yet. So that's why we created this destroyed variable to store which one got destroyed, so that after we finish this loop, we can remove it from our array. So that's what we're going to do. Destroyed equals target. That's it. Otherwise, well, they didn't destroy the target, so we will use the targets on click function to figure out what it should do. So target on click, do your thing. And finally, I'm going to put a break here. The reason why I'm putting a break here is I want it so that you can only click on one target at a time. If I did not have this, what you notice is that when we're running it, the different targets would go behind each other. Without this break, if you clicked on a target and there's a bunch of targets under them, you'd also get those ones as well. This says, once you've found a target that you clicked on, do the click on that target and stop the loop. So don't click on any other targets. If you got rid of that, then you would be able to click on multiple targets with one click. And that is about all we need for that loop. Now what we need to do is handle this case of, oh, they destroyed the target. And the way that we handle that is we just remove it from the list. How do we tell if they destroyed a target? Well, I set it initially to null. If it's not null anymore, they destroyed a target. So let's do that. So if destroyed is not null, then get our targets list and we're going to remove the destroyed target. There we go. And we can run it again, and we should now actually be able to click on them. They should change color, and after I click on them 3 times, they should disappear. Let's try it out, see if it works. So they're bouncing around. Come on. There we go. Oh, yep. Click on again, and 3rd time, gone. Click on it again, 3rd time, gone. Perfect. So, it's doing what we want. The only other thing that we need to do now is add the text that keeps track of how many targets are still remaining. To do that, we are going to create another object. So let's create a new file. And this is going to be just the score. Just like that. And once again, ignore all that. We will be doing all that anyways. So, creating a new score. Oh, that's why it's showing. Is it? I don't know. Weird. Looks like I'm team coding with myself. Alright, so let's create the object. We are going to need to import some stuff. So I'm going to put a little bit of room down here. We need to call it score because it has to match what the name of the file is, always. And just like before, we are going to have the 3 different parameters, or 3 different functions that I said that everyone should have. We should have, well, of course, the constructor method. And it needs to take in the sketch so that we can actually draw it to the window. Then we're going to have a void draw method to actually draw the text to the screen where we want it. And an update method that will update the text if we ever need to change it. So let's declare what variables we need. We're going to need to have one module. We're going to need to have the color again, so that we can create what color we want the text to be. And here we're going to need to have the different variables we have. So of course we're going to need to have something that keeps track, hold on to the sketch that we get passed when we're constructing it. We're going to have a couple different strings. We're going to have a static string. These should all be private. Not supposed to be changed by anything outside the class, so that's why I make them private. This is going to be the base string. And it's going to just be the part of the text that doesn't change. And so number of targets remaining. That part doesn't change. All we're going to do is we're going to take this, add number of targets remaining at the very end, and that's going to be the string that we display. We're going to have just a basic string of text to hold on to what it is that we're going to actually be displaying. We're going to need to have the text size. This can also be private. and it'll be size 25 to start off with. We can change it later if you want. And then we're also going to need to have a position. And we'll treat this as kind of the same way that we did position before. And this time I'm going to use an integer array rather than a floating array. But it doesn't really matter too much. This should also be private. If we want to change it, we can always add accessor and mutator methods to do that. Here's a new integer array. And you know what? We could just pass it when we're constructing where we want it to be. But for our purposes, I'm just going to put it in the top left corner. So I'm going to say it should be 20 pixels down from the bottom, or 20 pixels to the right of the left side, and 30 pixels down from the top. And we can adjust that to whatever fits our purposes as well. Score. So this is dead simple. All we really need to do is assign to our class variable the sketch that gets passed to it. So this sketch equals sketch. That's all our constructor method really needs. The update. We can't quite do yet. What we're going to need to do is we're going to need to go back to our sketch object and create an accessor method that will tell us how many targets are remaining, so that this object will know what to display. So let's go back to our sketch object and let's create an accessor method that will tell us how many targets are still remaining. So it's going to be a public function. It's going to return an integer called get targets left. And the way it's going to do that is pretty simple. It's going to return the size of our targets list array. And this is just going to tell us how many targets are in this still. Should start off at 10 and it'll just drop down. Okay, so this is our access array to get how many targets are left. And now we'll go back to our score and we can use that to actually create the text that we want. So the actual text that we're going to display is going to be our base string, and we're going to add to it how many targets they have remaining. Or targets left is what I called it. And this will automatically get converted to a string, so we don't have to necessarily cast anything. Draw method. It's not going to be too bad. First thing we need to do is we need to set the text size before we do it. Just like how we have to set the fill color before we actually create a shape, we have to set the size before we actually create the text. So text size is going to be the text size that we set it to. I believe I set it to 25. Then we need to set our fill color, and that's going to be black. And then now we're actually going to create the text. And so sketch, create some text, and it takes three things. First thing is, what is the text that we're going to be creating? That's the text that we create in our update function. And then what is the X and Y position of where it should be? And that's going to be, well, the X position and the Y position. There we go. That is our score class that's going to create text and tell us how long or how many targets are still remaining. Now we just need to go back to our main sketch class and add it to our code here. So we've already made our targets list. We're also going to need to then we need to create it, of course. So private, make a new score, call it the score, the new score, and it needs to be passed this sketch so it knows where to put everything. And then down here, the draw method, it'll take our score and call its draw method, and update, same thing. Make sure we're calling the update when we're updating everything. And that's it. That should now work. So let's try it one more time. Make sure, oh, we got an error. What's the error? Sketch fill black. Did I not properly make black our score? Oh, right. We need to make the color black. Let's do that. So private int black, the new color, the RGB value to black are zeros, and then we'll get the RGB value for that color. Yeah, that should work. There we go. Text shows up, says that there's 10 remaining. If I click on a target, drops down to 9. Exactly what we wanted. And because I'm drawing the text last, notice that all the targets are going behind the text rather than in front of it. The order that you draw things matters a lot. So that is as far as we're going to go for this tutorial. From this point, what you're going to need to do is you're going to need to comment on all the code that we've written so far. Notice that I did not actually add any comments as we were writing the code. Instead, I just talked about what we were doing as we were writing it, so that it's up to you in order to comment on everything and show that you understand what it all does. And then from there, you're going to need to expand on this to add your own personal touches. So for example, you might want to notice that once we hit 0, nothing happens. You might want to have an ability to start over again, so having like an end game screen or something. Maybe you might want to make a button class that they can click in order to interact with stuff that way. You might also want to have some sort of better score system rather than just saying how many targets are remaining. You can check to see how close to the center they actually clicked and give them a score based off of that, so a higher score for the closer to the center they clicked. You might want to make it so that when you click on a target, rather than just changing colors, it creates 2 smaller targets that are different colors. That can get pretty chaotic if you have too many targets going on, so you might want to start off with only like 5, and then it can kind of split apart. So lots of different things you could do with this. You could create a target that is a fake target that the player needs to avoid and not click, otherwise they lose the game. And how I mark you is going to depend on how much skill you show in that additional stuff that you add to this. Okay? So this is just a kind of basic intro to the processing module, how it works, and how to use objects with it in order to actually create something. And we will be revisiting this in a future assignment to get a little bit more experience of working with this kind of stuff. So we'll stop there, and I will see you next time. Adios.